This is Algebra 1, Lesson 4. There's a lot of terminology in Lesson 4. All right, we're going to begin by looking at the number system and how we represent the number system. All right, in the number system, all of our numbers are called real numbers, reals. The math symbol for reals looks like that. There are two types of real numbers. All right, they're either rational or they are irrational. Okay, rational, you can see the word ratio in it. Rational numbers are anything that can be written as a ratio or a fraction. Any number that can be written as a ratio or a fraction. Any mixed number is a rational number. Any number that has a limited number of decimal places. The decimal places don't go on and on and on. It's called a terminating decimal. 6 is your terminating decimal, okay? That is a rational number. Any decimal number that has a repeat decimal. What's a repeat decimal? If I wrote this, it would be 1.333333 ... That 3 would go on and on and on. I put a line over the digit that repeats to infinity, okay? So any decimal that has a repeat number is a rational number. Irrational numbers are numbers like what we dealt with in solving for the circumference. Pi is irrational because pi has an infinite number of decimal places. So it's any decimal that has no repeat decimal. So 1.234567890 1 2 3. It kept going on and on and on. On and on and on. Infinitely. Let me change it so it doesn't repeat. 0 1 4 7 6. And on and on and on. If it went on and on and on, that would be an irrational number. All right? Any number that has no repeat, like pi, is an irrational number. Now, under rational numbers, we have integers. Integers are all of the numbers that you represent on a number line. So my set of integers goes all the way to infinity in the negative. -3, -2, -1, 0, 1, 2, and all the way into positive infinity. It's every number that we put hashtags, hash marks on the number line for. All the negatives, 0, and all the positives. Under integers are whole numbers. Whole numbers begin with 0 and only go in the positive direction. So it has a beginning point. Notice the integers doesn't have a beginning point. It goes infinitely in the negative direction and infinitely in the positive direction. But this one only starts with 0 and goes in the positive direction to positive infinity. Your counting numbers are your natural numbers. Counting, it has two names. Counting are your natural numbers. They begin, you know, when you play hide and seek, you don't start 0, 1, 2. No, you start with 1, right? 1, 2, 3. So it starts with 1, 2, 3 and goes all the way in the positive direction. Now, on a number line, we represent integers, okay? So if I had 3 plus -5, what does that tell me to do? It tells me to start at 0. I'm going in the positive direction 3. 1, 2, 3. And then I go back in the negative direction 5. 1, 2, 3, 4, 5. So that 3 minus 5 is equal to -2. All right, that is how we use a number line. So the -5 tells me to go in the opposite direction. The 3 tells me to go in the positive direction. If I were just to look at the numbers -2 and +2, they are opposite values. Because looking at the number line, -2 goes to the left, +2 goes to the right. All right, that's the number system. Now, multiplying and dividing fractions. Multiplying and dividing fractions. All right, if I have 4/5 times 2/7, I look crisscross. Just like this multiplication sign, I look at the 4 and the 7, I look at the 2 and the 5, and I see this only works if fractions are multiplied. I see if I can simplify them. If some number can go into both of them. And there's no number that goes into 4 and 7 or 2 and 5. So I multiply numerator times numerator, and I multiply denominator times denominator. Now, what if I had 7/3, I'm going to write a big multiplication sign there, times 30/9. Now I ask myself, does this numerator and this denominator, can I cancel anything out? Does anything go into 7 and 9? No. But look at this one. Does any value go into 3 and 30? And 3 goes into both of them. So before I multiply fractions, I simplify. Before we multiply, we simplify. 3 goes into 3, 1. 3 goes into 30, 10. Now I multiply 7 times 10, which is 70. I multiply 1 times 9, and that is 9. Now, what if I had a mixed number? What if I had 2 and 1/2 times 5 and 1/3? These are mixed numbers. I don't multiply mixed numbers. I make the mixed numbers an improper fraction. Let's look at 2 1/2. I make this an improper fraction by multiplying 2 times 2 and adding it to the numerator. And the 2 goes away. Or I could take, this is really, that's how I want you to do it. 2, the whole number times the denominator. My denominator doesn't change, and I add it to the numerator. So that's 1 plus 4, which is 5. Really, 2 is the equivalent, if I multiplied it by 2 over 2, is 4/2. And I would add it to the 1/2 to get 5/2. But the shortcut is whole number times denominator, add it to the numerator. Whole number times denominator, add it to the numerator. My denominator doesn't change. All right, so that's 5/2. All right, so let's look at 5/3. What did I say? Whole number times denominator. 5 times 3 is 15. Add it to the numerator. 15 plus 1 is 16. So that's times 16/3. Again, I look. Can I simplify before I multiply? Is there any number that goes into 5 and 3? No. What about 2 and 16? Yes, 2 goes into both of them. I divide both terms by 2. 16 divided by 2 is 8 before I multiply. 5 times 8 is 40. 3 times 1 is 3. So leave it as an improper fraction. You do not have to go back and put it as a mixed number. Okay, what about fractions that are divided? Okay, so let's take these same fractions and we'll divide. So we're just changing the sign. All right, so 4/3 divided by, we'll just do the ones in the textbook. This is B, divided by 15/8. Okay, earlier I said -2 and 2. Those are opposites. Those are inverses. That's the inverse. They're opposite. And when we have fractions, I'm going to teach you another. This is opposite, or they're inverse operations. They're inversely related, okay? We never ever divide fractions, but we multiply by the reciprocal. And what is the reciprocal of 5/8? I take the reciprocal. It is, I put the denominator in the numerator in the denominator. All right, what is the reciprocal of 3/4? It's 4/3. What is the reciprocal of 1/2? It's 2/1. What is the reciprocal of 3? Any number over 1 is its same value. I flip that 1 to be 1/3. Okay? So we multiply by the reciprocal. Then I ask myself, can I simplify before I multiply? 4 and 15, 3 and 8, so I multiply. 4 times 8 is 32. 3 times 15 is 45. The same way if I have an improper, if mixed numbers, let's say I have 12 and 1/3 divided by 2 and 1/6. First, I make both of those mixed numbers improper fractions. Take the whole number times the denominator. 12 times 3 is 36. Add it to the numerator. 36 plus 1 is 37/3. I do the same here. 2 times 6 is 12. 12 plus 1 is 13/6. Now we never ever divide fractions. We multiply by the reciprocal of the second term. So we take 37/3 and multiply. I move my 6 to the numerator, 13 to the denominator. 6/13. Now, I don't believe any value goes into 13 and 37. However, 3 and 6, 3 goes into both of them. So I divide both terms by 3, and then I multiply. So 2 times 7 is 14. I'm carrying my 1. 2 times 3 is 6, and 1 more is 7. 1 times 13 is 13. And you may leave it as an improper fraction. Look on page 18. It talks about some basic operations and the symbols. That is an equal sign. If we do not have an equality, then we would say it is not equal to. All right, now we're going to talk about some language. 2 plus 3 equals 5. In addition, the name, each term has a name. The name of the constants, it's a constant, it's a number, it's a numeral. The names of the numbers that we're adding together, they're called add-ins. What the add-ins equal after we add them is called the sum. All right, so you need to know this terminology. What about when I'm subtracting? When I'm subtracting, this first one is called the minuend. It's in alphabetical order, M, then S. This is called the subtrahend. All right, alphabetical order. Minuend minus subtrahend equals the difference. Okay, minuend minus the subtrahend equals the difference. So M comes before S. That's how you can remember it. Addition, both of those terms are add-ins and it equals the sum. When I'm multiplying, say 4 times 3 equals 12. So this language is going to be important when we get to word problems, okay? 4 and 3 are called factors. We multiply factors like addition. Both of these terms have the same name, right? And this 12, after we multiply, the result we call the product. All right, when we're dividing, it's different. 10 divided by 2 equals 5. This is what we're dividing up. It's called the dividend. We're dividing it up. You see the word divide in it. We're dividing it up. We're dividing it up by the divisor to get the quotient. So the result of division is the quotient. All right, now let's review. I'm on page 19. How do we handle decimals? When we multiply, divide, add, and subtract, how do we handle decimals? Look at 4.1. When we add decimals, we have to write the numbers one on top of the other and we line up the decimal places. So this is 4.1. I'm going to add 4.0016 and I'm going to add to it 0.0216. Look, this top number doesn't have a place here. You can always add zeros. If we're on the right side of the decimal place, you can add zeros. So we have the same number of decimal places. Our decimal in the solution stays at the same place. Now we're just adding. 0 plus 3 is 3. 6 plus 6 is 12. Carry my 1. That's 3. That's 2. That's 0. And that's 4. This 0 is important. It's a placeholder. All right, so you cannot lose that 0. So adding, we line up the decimal places and we add. Subtraction is the same thing. Subtraction, it's even more important that we have the same number of decimal places. So remember, it's minuend minus subtrahend. The subtrahend and the minuend have to have the same number of decimal places. So it says subtract that from that. So the minuend is the 4.0016. 4.0016. The subtrahend is the 0.02163. I have to have the same number of decimal places in my minuend as I do my subtrahend, so I'm going to write a 0. I can't say 0 minus 3, so I have to go to the previous one and borrow. I make that a 10. 10 minus 3 is 7. I also line my decimal places up. That's where it's going to go in the solution. 5, I can't take 6 from 5, so I go to the previous one and I borrow and make that 15. 15 minus 6 is 9. I can't take 0 minus 1, and I can't borrow from 0. I have to go all the way to 4, make that a 3. That becomes a 10, but I need to borrow again. That becomes a 9. That becomes a 10, but I need to borrow again because I need to make this the 10. Now I have 10 minus 1 is 9. 9 minus 2 is 7. 9 minus 0 is 9, and 3 minus 0 is 3. Okay, I had to borrow a lot for that one. Now when we multiply decimal places, we don't have to line up our decimal places. So I want to multiply 4.06 by 0.016. Now, what I do have to do is I have to note my decimal places. This top number, I have 2 decimal places. This bottom number, I have 3. In my denominator, and what my product is, I'm going to have 5 decimal places. I'm going to multiply 6 by every number in this top factor. So that's 12, carry my 1. 6 times 0 is 0, plus 1 is 1. 6 times 4 is 24. Now, I'm in this place, so I'm going to start when I multiply. I'm going to put it under this 1. 1 times 6 is 6. 1 times 0 is 0. 1 times 4 is 4. 0, I don't have to multiply those out. It's all zeros. It's all zeros. Now I add them, and that's 2, 7, 4, 6, 0, 0. I need 5 decimal places, so I start here and I go to the left. 1, 2, 3, 4, 5 decimal places. So the product is 0.06472. You always need a 0 to the left of the decimal place. There always has to be 1 digit to the left of the decimal place. Now dividing is different because my divisor cannot have any decimal places. So when I move the decimal place in my divisor, I also have to move it in my dividend. All right, so it says divide 6.039, divide that by 0.03. That's my divisor. I cannot have any decimal places. So when I move my decimal place 2 to the right in the divisor, I have to move it 2 to the right in my dividend. So I'm going to rewrite this as 3 divided by 603.9. Now I can add any numbers to the right of that. I don't think I need to. Now I'm going to do division. 6 divided by 3 is 2. So what do? We divide, multiply, subtract, bring down. That's the process of long division. We divide it, we're multiplying, we're subtracting, bring down the next. Now I go back to dividing. 0 divided by 3 is 0. I divide it, I multiply, I subtract, now I bring the 3 down. I divide. 3 divided by 3 is 1. I multiply. I subtract. 3 minus 3 is 0. I bring down the 9. I don't need that 0 because I'm not going to have a remainder. 9 divided by 3 is 3. I divide it. I multiply. I subtract. I have no more numbers to bring down. So what's the quotient? 201.3. This is a long lesson, I know that. But it should all be review for you. Now, unit multipliers. All right, we're going to be converting feet to inches, yards to feet, okay? So let's walk through what this looks like, okay? Remember how I said crisscross is how we simplify? That's how I want us to see it. Okay, it says use 4.5 on page 20. It says we're going to use a unit multiplier, so it's going to be some value over some value. It's going to be a fraction. Unit multipliers are fractions. They're equivalent fractions, like 12 inches over 1 foot. That's the same value, right? Or 3 feet over 1 yard. That's the same value. So I want to convert 32 feet to inches. This is the same thing as 1. I want to end up with inches. So I multiply it. I want my feet to eliminate, so I put feet in the denominator. That's the same thing when we had numbers. Like when we simplified, right? We simplified 2 to be 1 and 4 to be 2. Our feet cross out. So if I want inches in the numerator, and whatever one is in the numerator here, I want in the denominator in my conversion. So then I ask myself, feet and inches, what's the equivalence? Well, 1 foot is 12 inches. And your textbook doesn't multiply this out. You do not have to multiply this out. So what am I left with? 32 times 12 inches. And what have we done? 32 feet is the same thing as 32 times 12 inches. Look at 4.6. Use unit multipliers to convert 36 feet. I want to go to miles. So I need feet in the denominator to eliminate feet. And I end up with miles. All right, well, this is a multiplier, unit multiplier that you need to know. 1 mile is equal to 5,280 feet. I multiply numerator times numerator, that's 36. Denominator times denominator, 5,280. I could divide those, couldn't I? I could say 36.000 divided by 5,280. I ask myself, how many 5s are in 36? I think about 7. I probably will go to 6. So I multiply. That's actually going to go over 1, isn't it? Because 5,280 does not go into 360. 5,280 does not go into 3,600, so I have a 0 there as well. But I can make it go into 36. That's when I just do 36 divided by 5 is about 7. I'm going to go down 1 more to 6, then I multiply. 6 times 0 is 0. 6 times 8 is 48. Carry my 2, 4. 6 times 2 is 12. 12 and 4 more is 16. 6 times 5 is 30 and 1 more is 31. I subtract. I have to go all the way to the 6 and borrow and make it a 5. That becomes 10, but I have to borrow again, making it a 9. That becomes 10 because I can subtract 0. 10 minus 8 is 2. 9 minus 6 is 3. 5 minus 1 is 4. You just want to make sure this number is smaller than that number. Now we can add another 0. I only believe this goes out 4 decimal places. Now, how many times does 5 go into 43? It's about 8, because 8 times 5 is 40. So because I still have 3,000 more to go, I'm going to go ahead and use 8. 8 times 0 is 0. 8 times 8 is 64. Carry my 6. 8 times 2 is 16. And 6 more is 22. Carry my 2. And that's 42, and I have a small remainder. So this is how many miles. You could actually take this and begin simplifying it. We'll learn simplifying fractions, okay? Now let's look at 4.7. So to get from feet to miles, we multiply by 1 mile over 5,280 feet. Now let's look at the next example. Use 1 unit multiplier to convert 47.25 inches. So I know I'm going to use a multiplier. So I want inches in the denominator. And what am I converting it to? Centimeters. Centimeters. So 1 inch, you'll need to know this fact, 1 inch is 2.54 centimeters. All right, my inches, that measurement cancels out, and I end up with 47.25 times 2.54. I'm left with centimeters. Okay? Look at 4.8 on the top of page 21. And your textbook doesn't multiply those out. Use 1 unit multiplier. So what have we learned so far? 1 foot is 12 inches. 1 mile is 5,280 feet. All right? We learned that 1 inch is 2.54 centimeters. Here's all the unit equivalents that we've used. These are unit equivalents. All right, now we're at meters. 42 meters. We want to go to centimeters. So I know I want centimeters in the numerator, meters in the denominator, so my meters cancel out. And 1 meter is equal to 100 centimeters. That's the unit equivalency that we're gonna write. So 1 meter is 100 centimeters. I can easily multiply 42 times 100. It's 4,200. I'm left with centimeters. Okay, look at 4.9. Now we have to use 2 of these unit multipliers. Okay, it says to use 2 unit multipliers. I want to go 42 feet, and I want to end up with centimeters. I want to end up with centimeters. So, to get from feet to centimeters, I have to go feet to inches, then inches to centimeters. All right? So I have to go from feet to inches, so my feet cancel out. And I don't want inches, I want centimeters. So I want to cancel out my inches, so I'm left with centimeters. Now I just write my equivalency. 12 inches in a foot, 2.54 centimeters in an inch. So what am I left with? 42 times 12 times 2.54 centimeters. That's my measurement that is left. Last example. Last example. Use 2 unit multipliers to convert 4 miles, and I want to go to inches. So I want to end up with inches. Well, to go from miles to inches, I have to go from miles to feet, then feet to inches. So I don't want miles, I'm going to feet. So 5,280 feet in 1 mile. My unit measure mile cancels out. I need to cancel out feet and go to inches. So I have inches in the numerator, feet in the denominator, so my feet can cancel out. 1 foot is 12 inches. Multiply numerators times numerator. Denominators are all 1. So it's 4 times 5,280 times 12 inches. And you do not have to multiply those out.